Abraham Michelson was the winner of the 1907 Nobel Prize in Physics. He was also born in Kingdom of Prussia, which is sort of modern-day Poland, to some Jewish parents before moving here to the United States at the age of 2. They got to the United States, they moved to California, followed by Virginia City, Nevada, where Mickelson's father was a merchant. Remember, this was gold rush country when the gold rush was still going on. Most people who went out to mine gold didn't necessarily make any money doing that. The only people who typically did were people who were merchants or tavern owners or people who owned the local gambling hall. So perhaps Mickelson's father was another smart cookie in the family. At this point, Michelson was already impressing people academically. In 1869, President Ulysses S. Grant awarded Michelson a special appointment to the U.S. Naval Academy. While at the Academy, he excelled in topics like optics, heat, climatology, and technical drawing. After graduating, he spent 2 years at sea, and he returned to the Naval Academy in 1875 to become an instructor in both physics and chemistry, where he stayed until 1879. In 1879, he was posted at the Nautical Almanac Office in Washington, D.C., which is part of the United States Naval Observatory, which is currently, among other things, the home of the United States Vice President. In the following year, he obtained a leave of absence to continue his studies in Europe, where he visited universities of Berlin and Heidelberg, Collège de France, Polytechnic in Paris. Remember, this was before World War I, so everybody was still friends at this point, and we were all still learning from one another as best we can, which I think is part of why this time period in science was so fruitful in advancing things. Everybody kind of got along and worked together. The Nobel Committee, when he was awarded the prize, awarded it for his, quote, optical precision instruments and the spectroscopic and meteorological investigations carried out with their aid. So what they mean by that is he built some of the world's most fantastic measurement equipment for things that would help you investigate the universe, everything from the speed of light to meteorological events are all done with his equipment. And what we're going to see in a moment is that his equipment and his designs are still influencing scientists and experiments that are conducted today. What Michelson was known for was building incredibly sophisticated and incredibly delicate lab apparatus. During June and early July of 1879, Michelson refined experimental apparatus that were developed by other scientists. The experimental setup was basically as follows. Light was generated from a source. It was directed towards a rotating mirror through a slit on a fixed plane. The rotating mirror would reflect that light at a certain angle towards the direction where another fixed flat mirror is placed, whose surface is perpendicular to that incoming ray of light. And as the mirror should have rotated through a particular angle by the time the ray of light travels back to it and is reflected again towards the fixed plane, you can get some measurement from working out the mathematics of all those observations to give you some idea of what the speed of light is, which was still not very well known at this time. His first experiments with the Michelson-Morley apparatus were at Annapolis in 1877 as part of a class demonstration. He further refined those over the next couple of years until he got a measurement that was then published, which came within 72 kilometers a second of the accepted number today for the speed of light. Considering the speed of light is very close to 300,000 kilometers per second, I think for an experiment done in the late 1800s, we can call that pretty gosh darn close. He wasn't quite finished. He and his pal Morley were still working at it. They wanted to know more about how light traveled and its speed through different forms of media. They had the speed in air. Now they wanted to know what the speed was in this thing called the ether. Since the time of the ancient Greeks, people had just assumed that light must travel through something. So they assumed that in outer space there was this sort of made-up thing called ether that was out there, that must be out there because it has to be. There can't be nothing there. There can't be space. It can't be vacuum. So they tried to measure the speed of light through that ether, and what they got was a null result, showing that the ether did not exist. Not only did our friend Michelson here win the Nobel Prize for his CAFRO measurements in the late 1800s and show us what the speed of light was and get rid of this silly notion of an ether that Einstein later said can't possibly be right. He had the math for it, and of course Michelson had the experiment, and there's a controversy that says, did Einstein know about it? And Einstein says he didn't, but irrelevant of all that. Michelson proved that it wasn't there even before Einstein published his papers later on showing that it couldn't possibly be. But even today, the Michelson experiments are taking place, but they're being used, those apparatus are being used for different things. And shown here is a facility at Caltech where the Michelson apparatus in a more advanced state is being used to search for gravity waves. Gravity waves are an ongoing part of physics research even today. So here it is, Michelson from the late 1800s, still contributing to science in the year 2024. That is a Nobel Prize worth remembering.